Hey guys, so I want to do two more problems for you. For those of you who were in class today, March the 3rd on Friday, I'm going to do two problems. One is just going to be a molar volume problem, one we haven't seen before, and one's going to be a full gas stoichiometry problem, okay? So these are found on page 469 in your textbook. It's number 84 and 85. So I've already written the balanced equations for both of these reactions on the board. And if you want to read along in your book, you can grab that. So I'm just going to read them to you, and then we'll put the information that we need. So let's look at number 84 first. Pardon me. Ammonia is formed by reacting nitrogen and hydrogen gases. How many liters of ammonia gas can be formed from 13.7 liters of hydrogen gas at 93 degrees Celsius and a pressure of 40.0 kilopascals. So let's just write some information down. It says that, so how many liters of ammonia? So here is our ammonia. So this is going to be how many liters? So that is the question that we're being asked. How many liters can we form from, and this is, what are we given here? Is it hydrogen? Yes, so it's 13.9 liters of hydrogen is, 7, pardon me, 7? 13.7 liters of hydrogen is reacting. And it gives us a pressure and it gives us a temperature. And we can certainly make note of that. And if we were needing to know the number of moles of hydrogen, then we would need to use that, and it would be the ideal gas law. But because this is just asking us for the liters of ammonia, that information is not going to be used because we can just use the molar, the mole ratio from the balanced equation, right? Because we know that this whole reaction, when it takes place, when those reactants come together, the pressure and the temperature is going to equalize and will be the same. So this will be 13.7 liters of H2. And then we're going to write the balanced equation ratio. So 3 liters of hydrogen over 2 liters of NH3. Can we still see that? We're not off the board. All right, I'm going to write the answer down here. All right, so let's grab our calculator. So this will be 13.7 times 2 divided by 3. So we're going to get 9.13 repeating, and we have 3 sig figs in our original piece of information, and that's going to be liters of NH3. Right? So that's how we're going to solve that. We didn't need the pressure and the volume here, or the pressure and the temperature, sorry, we were given. We did need to use the volume because we were looking at the molar volume and volume to volume ratios that the balanced equation honors. Let's look at number 85. 85 says that we have a 6.5 liter sample of hydrogen sulfide, and that it's treated with a catalyst to promote the reaction. And then the book actually gave us this reaction here. It says, if the H2S reacts completely at 2 atmosphere and 290 Kelvin, how much water vapor in grams is produced? So let's look at a couple of things here. We know that we have 6.5 liters of the hydrogen sulfide reacting at the beginning. So this is 6.5 liters of the hydrogen sulfide. And the question says, how many grams of water vapor? So it's question mark grams of the water vapor. So we know from previous stoichiometry problems back in chapter 11 that we can't go straight from moles to grams of any other substance. So we can't go from liters to grams of a substance. We have to find some commonality, something that they have in common. So we need to change the conversation here, right? So we're going to take 6.5 liters of H2S. And we are going to use the balanced equation relationship. So we're going to put, it says that we have 2 liters of H2S. And we have 2 liters of H2O. Just remembering that those stoichiometric coefficients also mean relative volumes, just like they mean moles, okay? So it's 6.5, right? So this is going to be 6.5, and I know we always want to go, well, why did we even have to do that? So the words will work out, right? Because we're going to cancel liters here, okay? So that has changed our conversation, so that now we're talking about, oh, I left out my unit, didn't I? Liters, that's liters of oxygen. Water, of the water vapor. Now we need to do another bit of business. Now we have a volume. And if we look back at the original question, we also have a pressure, right? So we have a pressure that's equal to 2 atmosphere. And now we know what the volume is. We know that the volume is equal to 6.5 liters. And what else do we know? Oh, we don't know the number of moles that is, right? So maybe that's our question. Maybe we're looking for the number of moles. R is a constant, so we're always going to be able to tell what that is. And let's write that in just a minute. And then do we have a temperature? We have a temperature, yes. Right here in the question it says that we are at 290 Kelvin. Now let's look at that R. Because the pressure is in atmosphere, we're going to use 0.0821 liter atmosphere mole Kelvin as our R unit, right? So we're solving for the number of moles. Okay? So now this is the ideal gas law. So we're just going to fill everything in. So this is PV equals nRT. So the pressure, the pressure is 6.5. All right, and the volume is, that was the volume, wasn't it? Actually, well, let's leave that. I'll put the pressure here. The pressure is 2.0, right? 2.0. So the pressure is 2.0. The volume is 6.5. N, we don't know. The R is 0.0821. And the temperature is 290. Okay, so now to solve for N, let's do this way. N is actually, so it would be these two numbers, 2 and 6.5, divided by 0.0821, divided by 290. All right, so the 2 atmospheres of pressure, and that get that point in there. All right, so when we solve for N equals, let me grab my calculator. I haven't actually calculated this out. I'm looking here at the previous answer. So what do we have here? 2 times 6.5 divided by 0.0821 divided by 290. All right, so the answer is 0.555. 0.55 is what we're getting for the value of N, and that's mole. All right, and now what can we do with that information? And that's All right, so that's mole. And then we're going to take that and convert that to grams. Now that is, what are we talking about here? Let's go back and look. That was about water. So now we're going to say that 1 mole of water has a mass of 18 grams per mole. And so that number times 18 is going to give us 9.8 grams. 9.8 grams. 2 sig figs, I think, is what we're stuck with. Yeah, we're stuck. So 9.82 grams of H2O. All right. So if we've been given a pressure and a volume and a temperature, we've already found a volume because we had a relative volume of another gas at the beginning, then we can actually work through and solve those problems. Okay, so take a look at that. That might help you. You may want to try another problem. These are from the Mastering Problems at the back of the book. We'll be looking at a few more of those before test time. Okay, have a good weekend. Bye.